Now, let's talk about exactly how we protect that data, right? So we talk about data centers, the network, but what do we do to protect that the data itself, right? So let's talk a little bit about that. First of all, every time that you connect to Google, you do it through an encrypted connection. As a matter of fact, there is no way to connect to Google through a non-encrypted connection. And this is a very, very strong connection, very strong encryption. As a matter of fact, the kind of encryption that we use to connect to any Google API is stronger than many commercial VPNs out there and even some military VPNs out there. Now, when you give us data, right, we're going to take that data and we're going to put it in a database that belongs to you. So we're going to talk a little bit about that in a minute, but just to give you a sense of exactly how that works, right? So the way we handle your data is based on a user first and application later. What I mean is we don't take, let's say, all the Gmail data and global together with other users. You will have your Gmail data in your database. And then now we need to protect that data. Every single piece of data that you give us is always protected in transit and at rest. You don't need to pay anything to do that. You need to enable it. There is no switch. There is no knob to even disable that. Every single thing that you give us is always encrypted. Again, in transit through this encryption, but also at rest every single time. So, how do we do that? How do we do that? Okay, so let's say that you upload a file, just to give an example, right? Let's say that you upload a file to something like Google Drive, right? The enterprise Google Drive, or maybe the Google, the GCP binary storage, right? Similar to what like AWS has with yesterday. So you give us a file, right? Through this encrypted connection, so it's encrypted in transit. When it gets to us, it goes to a data layer, and now we need to protect the data. So this is how we do. We take that file, and the first thing that we'll do is we'll split it into thousands of small pieces. Then we're going to take every single of those pieces, every single of those fragments, and then we'll apply algorithmic-based encryption. That's going to garble those files. It's going to make them unrecognizable, right? And it's going to use non-human names to name and identify those files. So now we have thousands of pieces, each one encrypted through algorithmic encryption. Now we take each of those pieces and then we apply standard key-based encryption to each fragment independently. Then we take those keys that we use to encrypt every segment, and then we encrypt that key itself. We wrap the keys into another encryption. So that's the third level of encryption applied to it. And then we put that in our key management system. Right? So that might, that probably went a little fast, but let me go over that again. You give us the file, you give us a piece of data, we split it into thousands of fragments. We first apply algorithmic-based encryption to it, then we apply key-based encryption to it, then we wrap that key again, encrypt it again, and put in our KNS. So imagine what has to go wrong for somebody to be able to reproduce that file. If someone went to get into those data centers, somebody's got to go and get the master key to encrypt each one of the data keys for each of the fragments, and then figure out how to assemble those fragments together. That is encryption at the data fragment level, right? At the file level, or the drive level, right? And that's incredibly superior than anything that you can build out there on-prem.